Good morning. I am Professor Karuppaiya, head of the Department of Technology, Lecturer Engineering College. I would like to present a video lecture on centrifugal pumps. It is very important topics in the fluid mechanics chapters. It's mainly the principal impeller head losses and efficiencies, minimum standard, NPS sketch, performance curves. It's very important. Examination point of view, it's also very important. Characteristic curves, cavitation effects, multi-stage ventricle pumps and reciprocating pumps. There are many. Introduction about a pump is nothing but the mechanical energy is converted into hydraulic energy by centrifugal force. The flow is radial, outward directions. This is the principle behind the forced vortex flow. What is the use of a centrifugal pump is water, sewage, petroleum, petrochemical pumping from one place to other place. The diagrammatic view of a centrifugal pump with motors, electric motors. The main parts is a impeller, delivery pipe, suction pipe, driving shaft, shaft sleeves, casings. These are the important parts of the principle behind the centrifugal pump is forced vortex flow. Means the fluid is rotated by the external torque rise in pressure place. Conversion of energy into two main parts by the two main parts of the pumps. One is impeller, another one is a casing. The impeller converts driver energy into kinetic energy. The diffuser converts the kinetic energy into pressure energy. This is very important point. The energy, driver energy is converted into kinetic energy by the impeller. The kinetic energy is converted into pressure energy by the diffuser. This is a very important point. Remember it. Next, the components of the pumps. This is the examination point of view. The diagram may be asked repeatedly. First one is the section of eye, impeller, and vans, volute casings, discharge, delivery pipe, foot valve and strainer, casings, everything. Each and every part, the impeller is nothing but is the important parts, rotating parts in the centrifugal pump. It consists of backward curved vans. The impeller is mounted on the shaft, which is connected to the shaft of an electric motor. Next, casing. Casing is the centrifugal pump similar to the turbines. The function of casing is the kinetic energy of the water is discharged at the outlet of the impeller is converted into pressure energy. Already I told you the impeller is nothing but conversion of kinetic energy into pressure energy. Suction pipe with the foot valve and a strainer. One end is connected to the inlet of the pump. Another end is a deep pump connected to the sump. Is known as a suction pipe. The foot valve or NRV, non-return valve, one-way type, is fitted in the lower end of the suction pipe. The foot valve opens only in upward directions. The strainer is fitted in the lower end of the suction pipe. It is for a filtration purpose. Delivery pipe connected to the outlet of the pump and other delivers water at a required height is known as a delivery pipe. This component is impeller. The component is impeller. This is a different type of casings, volute casings, vortex casings, and diffuser ring casings. These are the different type of casings. Volute casings, nothing but the spiral type of area flow increases gradually. Area is gradually increasing. Velocity decreases, area of flow decreases, the velocity of the flow. The decrease in velocity increases the pressure of the water flowing through the casings. The efficiency of the pump increases slightly as a large amount of energy is lost due to the formation of the eddies in this casing. In the case of vortex casings, circular chamber is in between the casing and impeller, known as the vortex casings. The circular chamber, the loss of energy due to formation of eddies is reduced considerably extent. The efficiency of the pump is more than that of the volute casings. Next one is a casing with guide blades. The impeller is surrounded by the series of guide blades mounted on the ring, which is known as a diffuser. The guide vanes are designed in such a way that the water from the impeller enters the guide vanes without start. Also, the area of the guide vanes increases, thus reducing the velocity of flow through the guide vanes. The guide vanes then passes through the surroundings casings. In most cases, the cases concentric with the impeller. Most of the cases concentric with the impeller is used. This is a diagram components of the how the pump works. This suction pipe, one common size is larger, pump inlet, and then the motor, outlet, everything is shown. And the blue color is a motor as well as the pump. Both are monoblock connected in this diagram. And then how the pump is work. From this diagram you understand. The liquid is forced into the impeller first. The vans passes kinetic energy to the liquid. The liquid rotates, leaves the impeller. Volute casing converts kinetic energy into pressure energy. The diagram already inlet, outlet is there. Impeller, impeller, van. Eye of the impeller is very important. The center parts, eye of the impeller. Central pump has two main components. One is a rotating component, another is a stationary component. Rotating component, impeller and shaft. Just a minute. The stationary component, casing, case cover, bearings, everything. Next, work done by the impeller. Work done by the impeller on the water. W is equal to V U2 VW1 U1 L divided by G. W is the work done per unit weight of the water per second. VW is a viral component, the absolute velocity of the jet at the outlet. Tangential U is the tangential velocity of the impeller at outlet. VW1 is a viral component of the absolute velocity jet at inlet and outlet. Outlet is 2, inlet is 1. U1 is a tangential velocity of the impeller at inlet. 1 suffix means inlet, 2 suffix means outlet. That's all. As the water comes radially, gate blades angle at the inlet is alpha is equal to 90. Alpha is equal to 90 degree. VW1 equal to 0. Then W is equal to UW2 by UW2 U2 by G. And the UW1 is 0, so that term will be reduced. First term will be reduced 0. Okay. Next, the heads in the centrifugal pump: suction head, delivery head, static head, manometric head. These are the different heads in the pumps. Vertical height of the center line of the pump above the water surface of the pump from the water to be lifted is called the suction head. Delivery head is the vertical distance between the center line of the pump and the water surface in the tank to which the water is delivered is called delivery head. Water to be lifted in a suction head, water to be delivered in a delivery head. Static head. Sum of the both suction head as well as delivery head, that's called static head. Sum of the suction head and delivery head is called static head. Manometric head, the head is again which a centrifugal pump has to work according to the formula HM. Manometric head is equal to HS plus HD, HFS, HFD plus VD into VD divided by 2G. These are the diagrammatic view of the HES section, HD delivery, total static head, capital H, casings, delivery valve, suction valve, Suction pipe, sump. Please listen. The foot wall is foot wall and strainers is below the water levels. It is the end of the suction pipe. End of the suction pipe. It will be attached. Foot wall. Manometric efficiency. There are efficiency. Manometric efficiency, mechanical efficiency. Manometric efficiency is the ratio of the manometric head to the head imparted by the impeller. HM divided by VW2 U2 divided by G. Mechanical efficiency is the ratio of the power delivered by the impeller to the liquid to the power input to the shaft. W2 U2 by G. All divided by power input to the pump shaft. Overall efficiency ratio of the power output of the pump to power input of the pump or shaft. WQ the HM divided by P. WHM divided by P. Losses. There are three types of losses are there. One is hydraulic loss, mechanical loss, leakage loss. Three types of losses are there. There are three losses are there. Hydraulic loss, mechanical loss, leakage losses. Hydraulic loss is nothing but the losses in which the pump consists of shaft at entry or exit of the impeller, friction in the impeller, friction in the guide vanes and casing. These are all called hydraulic losses due to water. Mechanical losses means the friction between the main bearing and the glands, friction between the impeller and the liquid, which tilts the space between the impeller and casing. This is called mechanical loss. Mechanical loss between the bearings, glands, in between the impeller and casing. This is called mechanical losses happened. Leakage loss, where it is complete watertight sealing at the suction and delivery pipes. Thus the liquid at very high pressure shifts to low pressure zone. Thus it never passes through the delivery pipe. Thus energy possessed by the liquid at high pressure zone is wasted due to leakage loss. This loss of energy is mainly due to leakage. It is impossible to control. These are the minimum speed for starting a centrifugal pump. It's a formula. Starting delivery liquids, pressure rises impeller is more than equal to that of manometric head. Just to change small formulas. V2 square minus V1 square divided by 2G, U2 square minus U1 square by 2G plus VR1 whole square, VR2 whole square divided by 2G is equal to U2 square by minus U1 square divided by 2G. The flow will be comes only if the H manometer is this U1. For a minimum speed is equal to this one, and also the manometric head is called that. This is a formula for find out the U1 and U2. U1 is equal to pi dn divided by 60, pi d2 by 60. Substituting the values in equation 1 previously, we can finally get a n minimum number of rotations per minute. Minimum is equal to 120 into n, VW2 into d2 divided by pi into d2 square minus d1 square. Priming. Priming is very important. Priming is a centrifugal pump definitions according to this section of the pipe. It will be carried section of the pipe, casing of the pump, portion of the delivery pipe, delivery value is completely filled with water. And then these parts are pump is filled with water. Air is removed from these parts, suction pipe, casing, pump, portion of the delivery pump also. This is called priming. Priming is nothing but removal of air from the suction pipe, casing of the pump, and portion of the delivery pipe. It's called priming by using water. Or what are the fluid we are going to transferring from one place to other place, that may be filled with. This is how the priming will takes place. Initially, the diagram shows priming port. Priming port is nothing but just small taps are there. Just to remove the tap, the air can be removed through the taps. The air inside the centrifugal pump. First. Next diagram is a priming starter. Priming means the water occupy the impeller suction as well as the delivery pipe, and then continue means it will pull the water from the storage tank, discharge it to the outside. This is last third figure shows pump is running. Specific speed of the pump is defined by the speed of the geometrically similar pumps which deliver a unit quantity. 1 cubic meter of liquid per second. Unit head means 1 meter, denoted by NS. Specific speed means NS. The formula will be shown. Q is equal to pi d1, B1, Vf1 is equal to pi d2, B2, Vf2. Directly proportional to d in diameter, and then dn is equal to root of manometer head, and diameter is equal to root of manometer head divided by n. Q means nothing but volumetric flow rate, root of h m divided by n whole square, and then root m into root m. The final formula is Q is equal to 1 meter cube per second. Hm is equal to 1 meter. C is equal to n. Is known as specific heat. Ns is equal to n into root of Q divided by Hm whole by 3/4 in the denominator. NPSH, it is also very important, net positive section head. It's defined as the difference between the net inlet head and the head corresponding to the vapor pressure of the in liquid. NPSH may be defined as a net head in meters that is required to make a liquid flow through the section from pump sump to the impeller. NPSH is the absolute pressure head at the inlet pump minus vapor pressure head plus elastic head at the inlet of the pump. The formula P1 minus rho g minus PV by rho g plus V square by 2g. NPSH is equal to P atmosphere divided by rho g minus V square by 2g plus Hs plus H Fs minus PV by rho g plus V square S by divided by 2g. NPSH is equal to H atmosphere, Hs, Hfs minus Hv. NPSH total section head. It is given by the manufacturer. The distinction is between the required NPSH and the available NPSH. The required NPSH is varied from pump to pump, design to pump designs, speed, capacity of the pump, etc. NPSH must be greater than that of the required. Available NPSH always greater than the required NPSH. Okay. This is the formula. H is equal to H minus Hs minus H V square S by 2g. Suction lift. Suction lift is nothing but centrifugal pump lifts the liquid from the sump. So called suction lift. The free surface of the liquid is at the depth of height below the pump axis. The liquid is flowing velocity versus the suction pump pipe. H is the figure shown in the figure. H is equal to H minus H minus V square S divided by 2g minus Hfs. H is the atmospheric head, Hv is the vapor pressure head. This is again a diagrammatic view of the pump. Hs is nothing but surface of the sump, free surface to center of the pump. Velocity of the suction inlet V is impeller, I, outlet, everything is shown. Characteristics is very important regarding the examination point of view. Curves, there are three curves: main characteristic curves, operating characteristic curves, constant efficiency curve. There are three curves are there. The curves are necessary to predict the behavior and performance of the pump when the pump is working under the different flow rates, head and speed. Main characteristics of the curves as a centrifugal pump consists of variation of head, manometric head, power and discharge. Operating characteristics karna, I think with respect to speed, if the speed is kept constant, the variation of manometric head, power and efficiency with respect to discharge give you a operating pressure of the characteristic. This is a diagrammatic view of the characteristic curves. X-axis speed, y-axis power, head, discharge. The different lines are there. One is Q and H constants. Only pressure vary. Next curve is Q is constant. H is directly proportional to speed. Next one is HM is constant. Q is directly proportional to N. This is an examination point of view. This curve can be asked repeatedly. The students are interested how the curves are drawn, what is the importance of the curves. You have to repeatedly draw the curves. Yes, examination point of view, characteristic curve of pump, centrifugal pump may be asked. X-axis discharge, x-axis discharge Q, flow rate. Y-axis efficiency, power, head. Y-axis. The different lines are there. One is called head lines, another one is called efficiency lines, another one is called power, another one is called output power. Okay, these are the important curves. Next is the constant efficiency curve. For obtaining constant efficiency curves of the pump, the head versus discharge curves, efficiency versus discharge curves for different speeds are used. Different speed, that's called N, already I told you, N. Discharge, that's for discharge, different discharges, efficiency and head. Cavitation is the main phenomena, formation of the vapor bubbles. Vapor bubbles where the pressure falls below the vapor pressure, the flowing fluid. Collapsing of the vapor bubble causes a high pressure, results in noise. Pitting actions on the metal surface, erosion, noises, vibrations are produced. Cavitation can damage the pump. Okay, you observe the damage of the pump impellers, cavitation. We have low pressure, high pressure, cavitation damages. The effect of cavitations, metallic surface are damaged, cavities are formed. Efficiency of the pump decreases. Unwanted noise and vibrations are produced during the cavitations. These are the damages due to cavitations. Multi-stages pumps, number of pumps, multi-stage, you will see. Two or more impellers are connected. The pump is called multi-stages, centrifugal pumps. To produce high speed, high head, high velocity, large quantity of water, two important functions. Multi-stage pumps for a high head when we mounted on series. Impellers are mounted in the series. Same shaft shown in the figure. Shaft will be same, but the impeller will be two impellers mounted two impellers for high head. Okay, high head. First impeller and second impeller are help connecting the pipe outlet, increases the flow rate. Multi-stage centrifugal pumps for high discharge. Each pump's common pump, the total discharge equal to N into Q. This is a parallel combination of the high discharge. Or you see the figure, there are two pumps are connected in troubles and losses. What are the troubles? What are the remedies? Lack of primes. Fill the pump and suction pipe completely with the liquid. It may be water or whatever the fluid we are going to transfer. With the help of the fluid, we have to fill the pump, suction pipes completely with the liquid. Air can be removed. Okay, that's very important. Lack of primes. Loss of prime. Check for leakage in suction lines, suction pipe joints, fittings, flanges. That's very important. Vent casing to remove accumulated air through the air cock. Okay, and then the discharge systems head too high. What's the trouble? Check the pipe friction losses. Larger discharges pipe may be correct conditions. Check the valves are wide open. Valves are wide open. Wrong direction of rotations. It may be also somewhere. Check the motor rotations. Clockwise or anti-clockwise. Directional arrows or pump casings. Wrong rotation causes pump damages. Impeller completely plugged. Dismantle the pump or use a piping head hole to clean the impeller and then again dismantle, assemble everything. Suction lift too high. If there is no obstruction at inlet, check the pipe friction losses. However, static lift may be too great. Measure with the mercury column. With the pressure. If static head lift is too high, the liquid pump cannot be raised. So pump will be lowered. Suction lift is too high means the pump will be lowered very near to the water level and then flow will be. This is a remedy for the suction. Speed too low. Check whether the motor is directly across the line receiving full voltage electricity. Full voltage alternating frequency may be too low. Motor may be an open phase. Okay. Reciprocating pump. Now we go to reciprocating pump. The pumps are used. The energy levels of water variation. Reciprocating pumps is the positive displacement. It is also called positive displacement pump. A small quantity of liquid is taken in a chamber, physically displaced force without any moving things. The main difference between the centrifugal pump and reciprocating pump here, there is no need of priming here. No need of priming in the reciprocating pump. No need of priming. Industrial purpose is very maintenance cost compared to centrifugal pump. It is high. Small hand operated pumps still include well pumps, etc. The useful where the high head can be required with a small discharge as oil drilling operations. Okay. Regarding the reciprocating pumps, consists of plunger and a piston, plunger or a piston that moves a forward direction as well as a backward inside the cylinder, connecting rod. The crank is rotated by an external source of power. The cylinder is connected to the sump by a suction pipe and to the delivery tank by the delivery pipe. At the cylinder ends of this pipe, non-return valves are provided. The non-return valves are always liquid to pass only in one direction. Through the suction valve, liquid can only be admitted into the cylinder. Through the delivery valve, the liquid can only be discharged to the delivery pipe. This is the diagrammatic view of the reciprocating pump. Piston is there, connecting rod is there, crankshaft is there, suction pipe, check valve, and then pump casings, and then discharge pipe. This is the diagram is very important. Reciprocating pump diagram. This is easy to understand how the pump works. Suction sump level, suction pipe, suction valve, delivery. There are two valves are open. One is a suction valve, another is a delivery valve. Suction valve open means only flow will be only in one direction only. The piston can be moved forward and backward by using crank. connecting rod. With the help of connecting rod, it can be, the crank will be rotated, the piston rod will move forward and backward. At the time, it will be, during the backward, suction takes place. During the forward, delivery will take place. Again, the reciprocating pump. Already I told you, the pump is started first time. After a long period, the air can be removed by suction stroke. Here no priming not required, only suction stroke. Suction stroke, a small height due to the atmospheric pressure and the sump liquid. During the delivery stroke, air in the cylinder is pushed out. So delivery thrust, so the suction valve is closed. And then when the air from the suction has been expelled through the exhaust head, then liquid from the sump can be occupy the cylinder. During the delivery stroke, it is displaced into the delivery pipe. The liquid is delivered, delivery tank, stroke only, delivery stroke only. Advantage of the pump compared to the centrifugal pump: high delivery head, high viscosity fluid can be sectioned by using the reciprocating pump. Solid also handled capability. Solid also handled. High pressure. Efficiency is 90% efficiency. Other disadvantages: the flow will be pulsation flow. The flow will be pulsating because during the forward and backward movement, the flow will be pulsation movement. Maintenance is also high maintenance, very high maintenance, short life. Life will be very short. For low discharging capacity, we can use it. Low discharging cannot be used. Thank you for your patient listening. I hope the lecture may be useful for you. Please don't forget to study characteristics of curve,